Swayam Prabha. Digital India. Educated India.
Dear students, we are now in the module 5 of the course Fire Safety in Buildings. So, in the previous modules we have learnt about the various methods of measurement of fire load, and then into the building materials part, and then further moved into the smoke part, and then we understood the passive methods of protection. Now, in this particular module we will try to cover the active fire protection systems. Mostly it includes the dry riser and the wet riser system, which can be integrated in the building system, and it is usually required for large scale buildings. Sprinkler systems which can take action exactly at the point of fire, that means it is to keep or confine the fire in one particular location and not allow it to spread. That is the primary principle of fire fire systems. And further, with the sprinkler systems, there are various types of other sprinkler systems. The deflectors are of different kind. Under the sprinkler system, we will also try to find out the network, how it is planned, and they are also following codes and standards. So, we will be continuing with that. Now, coming to a city framework. First, if we want to put any system of firefighting outside the building, that is also mandated by the rules and regulations, and it is called the external firefighting system. There we have to leave, you can see in this picture, we have to leave fire hydrants, on the road, or it may be flushed on the road water network. So, it is drawing water from the city water network, and there are certain important dimensions to be maintained. It is located around 90 to 120 meters apart, or in inhabited areas 300 meters apart, and one fire hydrant is expected to serve 4,000 to 10,000 meters square of area. So, it is like where there is a community, there is a housing complex and all. So, you have to have in the periphery such kind of arrangements, and water demand is expected or worked out based on 1 liter per person per day from the fire hydrant. So, these hydrants, the firemen can come and access the water and through their pipes, and they can use the water to control any external fire happening outside the building or in the premises of a housing complex or any commercial complex, etc. However, we will more focus on the internal firefighting system. So, this city system is for taking care from fire, any hazards outside. However, the internal fire system are independent of that, and it is dependent on the building infrastructure, building water, whatever is there, and the supply has to be from the building till the fireman reaches the building. Even the firemen are dependent on the static water, which has to be maintained or mandated by the local building code. So, we must look into how we combine or we can include this system within the building. So, there are different ways of suppression. These are all under active control, which refers to the control of the fire by some action taken by the person. It may be automatic or manual, it may be automatic or manual. Now, fire suppression systems you may have seen in various buildings. There are systems which are hung on the wall, and people are supposed to use it and target it towards the fire and start the ignition of such devices. However, in larger buildings or higher buildings, it is mandated that you have to have a standpipe system. Now, we will discuss on the standpipe system. Other than that, we can have automatic sprinkler system. Now, this standpipe system can also support the sprinkler system. Sprinkler system can be independently fed by water for control of fire at the point where it has started. Now, automatic sprinkler system, it is a kind of network which is fed by the water and they are activated due to the heat of the fire, and it controls the fire before the flashover happens. If you may remember what is a flashover, when the fire grows to its maximum and prior to that is the ignition phase. So, you do not allow the fire to grow beyond that. Now, let us come to the other systems. There are certain other systems which are hypoxic fire prevention system, which is not exactly like the traditional fire system. However, they extinguish fire after detection, and they reduce the oxygen in that area and protects the fire to spread further. We have already learned about the smoke control. Though it is mentioned here, it is also an active system, but it is a very different kind of system through which the smoke is controlled, and we have learnt it in the previous module in details. Other than that, the human actions, we will cover this part in the next module, which is the evacuation. So, the occupants can prevent ignition if they are aware that there is a hazardous situation. So, they can actually activate some alarm, they can timely start the rescue operation, they can inform the fire brigade, they can help the firemen to for their wayfinding, etc., though they have the plans, etc. So, setting up the water supply, the human actions also are required to activate the active fire control system. So, we will get into each of them one by one. Now, when we talk about the active fire control system, as I have talked about the standpipe system, there are two kinds which is coming under the standpipe system or the hose reel system, which is one is the fixed dry pipe system, other is the fixed wet pipe system. Usually these are integrated within the fire staircase, or if there is a fire lift and a staircase, or a fire lift, its staircase and a lobby. So, you can access these hose which the firemen usually do, and these are the pipe systems which feed the water into the hose. Now, if we go to the automatic fire suppression system, there is fire sprinkler system, there is deluge sprinkler system, there is pre-action sprinkler system, there is water mist system. So, we will take up in details fire sprinkler system as I have discussed in the previous slide also, but we also have a deluge sprinkler system when it is a case of a large scale fire, usually in hazardous building. Such kind of things are, or say a power plant, aircraft hangar, where there may be a lot of petroleum related fire, suddenly it increases. So, deluge, the word deluge means flood. It is like flooding, all the sprinkler nozzles open and it floods the area. However, the principle remains the same. So, we will discuss one type, and you can understand that larger procedure is applicable for the deluge system. What is the procedure? More amount of water pressure is required. Other is pre-action sprinkler system, like it is a computer lab, you do not want water over there. Like the deluge sprinkler saves the entire area because the fire is, because it is a hazardous area and the fire spreads very quickly. Unlikely the computer suits where we do not want the water to spread, there we can actually take some pre-action sprinkler system, and the openings of the sprinklers through which the water is spread, it is coming out in a very controlled way. And further fine is the water mist system. So, here the amount of water required is very low and it actually comes out in very droplets of water which displaces the localized oxygen and prevents burning. So, these have various different applications. However, the hose reel system is an integral part of any high rise building or any commercial complex or any say shopping mall or a cinema hall. The sprinkler system is very common and is seen in laboratory areas, workplaces where localized fire can be taken under control. However, the others are also having applications in industry or in hazardous areas or in, as I told, in computer suites where water is not much welcome. Now, coming to the two types of riser main or the hose reel system. As you can take from the word dry, dry means there is a pipe. Now, you can see in this picture that there is a pipe through and through, and you can see this arrowhead is up, and here you see there is a fire engine which has arrived, and here there is some inlet. So, this pipe is not having any water throughout when the building is not having any case of fire, and what you see at every floor there are valves. So, say at this floor there is a fire. So, what will happen? This pipe will be charged with water. You can see the arrowhead up. So, from bottom under high pressure, this pipe will be charged with water, and the fire rescue operation, they will open the valve at this particular floor and they will use the hose reel and attack the fire by drawing the hose reel till that point. So, what is important? The water pressure from here the pump here takes the water under pressure to this point. So, what is happening? Higher you go, the pressure drops, and there is a minimum. So, the pressure will drop, pressure drops. So, what will happen? This water cannot have or cannot maintain a high pressure at the upper points. It may be good for this level, this level. So, there is a mandated height. So, this kind of risers can be taken for 50 meters below building. These are mandatory for 18 meters plus building. So, buildings which are 18 meters plus must or mandatorily should have either a dry pipe system or a wet pipe system. Obviously, for wet pipe system the requirements are different. So, if your building is within 50 meters, you can manage with a dry pipe system. However, for heights beyond 50 meters, you have to go for a wet pipe system. It is not told that below 50 meters you cannot put a wet pipe system. So, you can even put a wet pipe system. So, today I will take you to our building in IIT Kharagpur campus, which is at 24 meters and it has a wet pipe system, and I will show you through a video how the entire system is integrated within the staircase block. Now, you see from the outside, this dry pipe can be fed with water from internal underground reservoir. So, there may be underground reservoir from which the water can be pumped in, and also the firemen bring a water tank along with them from that water to initiate the process and to control the fire within that time. so that the flashover does not happen, the action has to be taken. Now, as I talked about pressure, more higher we go, we cannot maintain the water pressure, the desired water pressure, which is actually 3.5 kg per meter of pressure. Similarly, on the horizontal direction also, we cannot go beyond 40 feet or 12.5 meters, because the pressure at the end or the end of the hose drops. So, what is important? My building height should not be more than 50 meters, my length of service should not be more than 40 meters. So, if I control from one point staircase, my hose pipe should not go more than 40 feet or 12 meters, 12.2 meters. So, my hose reel, if you have seen a reel box which has a pipe, flattened pipe which is wound against a spool, so we can pull it and it can go up to 40 feet. Now, along with this kind of system, sometimes we can also rope in the sprinkler system. You see here another option is there, dry pipe fire sprinkler system. Now, what is happening here? This dry pipe here is filled with some pressurized air and there is a remote valve at the top. So, this is I am talking of a second kind of system, which is a dry pipe fire sprinkler system. So, it is the similar thing with a valve at the top, and these are the at the specific locations there are pipes, instead they are supported by a sprinkler system. I will get into details of sprinkler system. They are supported by sprinkler system and that is the pipe. Now, how does this pipe gets charged with water? Because there is pressurized air, because of sensing the heat, some of these sprinklers at a particular floor gets opened, the nozzles open. What happens? Air enters through it. There is a fire here. The moment with the fire the nozzles open, this air, the pipe is filled with air. The moment the pipe is filled with air, that is that stack serving the taking the water, that top valve, because of the air pressure difference, opens and the water rushes in. The moment the water rushes in, it will take course, because the openings are only at this point. This valve particular floor opens and it takes the water to the seat of fire where there is fire, and from there the sprinkler operates and actually the fire is tamed or controlled. So, this is how a dry pipe system can be plugged with a fire sprinkler system, and the entire operation can be done. Otherwise, the dry pipe system and the wet pipe system, it is the main difference is in the dry pipe system the water rushes when there is a fire. On the wet pipe system, which is unlike the dry pipe system and which is applicable beyond 50 meters height, which is mandated beyond 50 meters height, there the water is coming from the overhead tank. Now, let us see the wet pipe system. Now, in this wet pipe system you see it is clearly written, it is mandatory above 50 meters, it is not told that it cannot be applied below 50 meters. So, you can always put it, and what is there? There is an overhead tank. Now, these overhead tanks capacity etc. are all mandated in the National Building Code 2016. Now, you see here there is an overhead tank, and this tank water allows to maintain a pressure. So, you see here the arrowhead is going down. So, the water reaches the particular floor, say where there is fire, say this floor is having fire, this valve will be opened and automatically the fire hose reel, which is also here in the staircase, can be pulled to the location of fire and it can be extinguished or controlled. So, what you see, the dry pipe system and the wet pipe system, their functioning is same. The firemen will actually rush through the staircase and will reach this particular floor and pull the hose. The difference is, in one case the water is fed from the bottom, in this case the water is fed from the top. But remember, the overhead tank has its given capacity and you may require more amount of water. So, immediately you see here there is again a pump which is pulling up water and feeding, the overhead tank, because the water supply is connected from the overhead tank only. So, from the overhead tank the water will come down to the place where the occurrence of fire and the firemen will control the fire, but the water will come from the overhead tank. Now, here also it is, you see there is an inlet to wet riser tank at 1 meter above ground level or the property labeled wet riser tank inlet, and here also the fireman comes and plugs in either their device or from the underground reservoir, which is also important, and they charge additional water to the overhead tank and or they operate the pumps so that the overhead tank is kept full and no dearth of water is there in case of uncontrolled fire. So, it is a built-in water distribution pipe system of valves and pipe work which is kept permanently charged with water, generally utilizing pumps and overhead tanks, ensures that water is immediately available at all floor levels. This provides better water pressure at the higher floors. As you can see, the immediately below these floors, there also are meters, pressure meters, which gives you the measurement of the air pressure or the water pressure, and the firemen can control it from there. So, in the video these points are specifically shown, which will give you a total understanding of how this system works. Now, in the video what you will see, it is the wet riser and you can understand that it will be similar in case of the dry riser system also. You see a point is written below. Combined systems for mixed height buildings and dry riser system for buildings with basements are mandated. So, if you have a building of large height, a portion of the building can be served with a dry riser system, a portion of the building can be served with a wet riser system. Now, again there is also a mandate that within 60 meters horizontal distance, there should be within 60 meters horizontal distance, there should be separate fire staircases which should be supported with this kind of wet riser or dry riser system. So, if you have a very long kind of building, usually institutional buildings, you must have fire staircases at given distances so that my hose reel operation can take care of the entire floor area. Usually 900 meter square is served. One is length, other is how much of meter square length can be covered. It is told that 900 meter square can be covered by one hose from one fire escape staircase which is having the hose reel. Now coming to the water demand, because as you understand the everything is controlled by the water and water should come from the water tank. So, you see that the magnitude of fire and duration taken to extinguish is the amount of water that will be required. So, we have a static water storage tank which is underground of a building, from where the pump is connected and the water is taken to the top level. So, this static water storage tank is first where the municipal water comes and gets in. So, that static water storage is always full. From there the next tanks, which are the reservoirs or the underground reservoirs, are supplied with the water. So, the static water storage never gets any stagnant water. So, there is no chance of any stagnant water in the static water storage. So, first the static water gets filled. So, automatically every day there is no case of fire. So, the static water overflow enters into the regular reservoir which is underground. From there the regular water is going up, whereas the overhead tank, as you had seen in this picture, the overhead tank water can be networked with the other tanks, so that no stagnant water or stagnation takes place. Now, you can see here NBC 2005, which is not amended, 2016, both have the similar kind of non static water requirement. For up to 15 meters it is not necessary, 15 to 35 meters it is not necessary, because it can be fed by a dry riser. From 35 to 45 you have to have a static water storage of 75,000 liters. Beyond 45 to 60 meters you have 1.5 lakh liters, and above 60 meters you need to have 2 lakh liters of water. Whereas, the overhead tank has its mandate, which for every building has to have a reservoir of 5,000 to 10,000, 25 and up to 10,000 liters capacity. Now, this can be spreaded into few overhead tanks, or it may be, and it can be connected, so that the overall demand can be always met in case of a fire. Now, as you see, we also need a discharge pressure which is 100 liters per minute at 3.5 kg per centimeter square pressure, as I already told you earlier, and that is shown in the meter which is installed on the pipe itself, which can check what is the pressure flow into the pipes. Now, coming to how will things start? The detection and the alarm system to alert the occupants in case of a fire. Now, you see this is a very schematic diagram, where you can see these are smoke detectors, because with every fire there is a smoke, and smoke detectors can give you a clue that there is a fire. So, what will happen? There should be some mechanism so that the alarm bell rings. So, when the smoke detector detects the fire, you can see the yellow line is coming, which has a supervisory switch. You can see here, which is a supervisory switch. So, what happens? The supervisory switch relays that information to the central center. You can see here, this is a picture of the control panel, where the light blinks, that from this point this sound is coming and the alarm is set. So, the alarm starts ringing at the particular floor, and you can see at the control station that this particular floor is on fire. So, the light starts blinking over there, or some sound is to make the people alert. and then you see there is a flow switch which actually is in an electromechanical device designed to send a signal to the local alarm. So, the local alarm of the floor starts ringing the bell. So, all these systems integrated together gives the information to the fire alarm control panel, which is shown in this picture here, which is in this fire control panel, and the alarm bell at the particular seat of fire where the fire is happening, at the floor of fire, not sorry, is starting giving hint that the people should be rescued from this area. So, it alerts the occupants of the to prevent the fire. Now, automatically you can see there are another system, it is a schematic picture. So, these are those sprinkler heads. It is shown as one, but it is actually a network, that also you can see in the video. Now, you see this sprinkler head further gets the information from this control panel, and because of the heat at that particular point, the sprinkler nozzles open up. I will discuss that when we get into sprinkler system. The nozzles open up and the water comes out to control the fire. But meanwhile, what has happened? The inhabitants or the occupants within the floor, within the building starts coming out, because you never know how big the fire can be or how damaging it can be. So, the people are to be rescued, which is the first or the primary target. Next is saving the building, and next is putting the building into operation. If you remember, you can recall from your previous lectures from my previous lectures or your previous studies that we need to take out the people, we need to protect the building, and we have to protect the documents etc. inside the building, and then finally, we have to start the building functional as soon as possible.
We are on the top of a 24-meter plus building, where you can see on the roof, we are standing on the roof, and you can see there is a designated tank, particularly written as fire tank. There is another one behind it. It is as per the guidelines, the amount of water or the volume of water it has to store, which is connected to a red pipe, which you can see here with a valve. So, in case of fire, the fire persons come here and they have to open this one. They open the valve, and the water is carried through the red route, which is along the periphery of the building, and it ends into a point from which it is taken down. So, the pipe from the roof, which is coming from that tank, is charged with water, and here there is a pressure meter. You can see it measures in pound per square inch or kg per centimeter square. Both the readings are there. So, accordingly the water pressure required in the hose is controlled from here, and the valves are opened so that the water reaches the particular floor and charges the fire hose. In case of a fire, the people who are actually trapped on the particular floor comes to the nearest fire exit staircase, because the lift is no longer in operation, and they actually get the panic bar which they can press and get access into the staircase. This door is actually highlighted in red, and the door automatically closes so that the fire or the smoke does not enter into the zone. Considering that this particular floor was in fire, what can the firefighting personnel who will be coming to this floor? First, from the bottom, that is the ground floor, they will access this particular floor, and they will come and actually open this space. If you remember, this is the pipe which was coming down from the rooftop, and here is the hose reel through which, on pulling, it can be dragged or drawn into this particular floor, and they can actually attend the fire to control it. Here you can also see there are valves, because without the valve the water will not flow into this particular flow, because if this is open then only the pipe will take the water and the pipe will be dragged into the location of fire to control it. As a further security reason or precautionary measure, you can see handheld fire extinguisher is also installed in within the safe zone, which is the fire staircase. So this is the firefighter's phone jack, which is operational under when it is emergency, and the firemen can actually connect to their personnel through this connection. And these are all special lines which remain active in case of fire. However, the main building services, building electrical lines gets closed down due to fire. This door is again a fire rated door, which can usually it is 2 hours fire rated as a mandatory. It has to be installed in a fire check staircase. Here the fire rated means it will be 2 hour fire safe also for this glass portion. So the entire assembly is fire rated. This glass is a tempered glass which can withstand high temperature. This allows visibility on the floor of on fire, and to check whether this particular staircase block is safe or less of smoke is inside it. We are in the ground floor of the fire escape staircase, where we can see that is the point of exit for the people who are trapped on fire. They exit taking the staircase from here. Parallelly, this is the entry point of the firefighters who enter into this building through this fire staircase. They have control on the water supply, which is fed to the fire hoses. The firemen actually move through the staircase to the floor which is on fire. They take help of the firefighter's phone, as you can see, and they take access to the floor which is on fire and try to control the fire and make the building safe.
Now, you can see this is also another picture where you see the system shows normal, everything is green, there is no light blinking, and this is an electronic system which is showing at a particular time everything is okay. Now, here you can see that the supervisory switch, the system warnings, the alarms, that is fire alarm action where it is active. So you can get the clue that what is happening in which floor, so that the building management system can call the firemen to take immediate action. Although the integral system within the building, if it is a sprinkler system, that activates and starts taking its action. So, smoke detector, heat detector, hand activated pull switch, manual call point, all can activate fire suppression. Fire sprinkler system can alert first respondent, simply sound alarm. So, all these can happen through the panel when it receives an information of a fire. So, this is again showing the water pressures. See 50 psi, 60 psi, 40 psi lower you go, and these are the, to maintain the water pressure within the sprinkler system, you have jockey pumps or the booster pumps. So, if your pressure is not maintained, you can start the booster pumps to increase the pressure within the fire sprinkler system. So, hydrant pump, sprinkler pump, jockey pump operate together simultaneously, or you can control it, and you can control you can check the pressure at the different points, because pressure meters are installed and you can actually control the pressure within the pipe system. Otherwise, if it is very high pressure, the pipe may also break. So, you have to control the pressure. Usually these are done by the firemen and they are expert on it. This is a small this is a picture, you can see the picture source has been mentioned here, which shows a picture of the mist foam water sprinkler system or the mist system, which is usually at hazardous areas which are installed. You can see it is a huge facility where this kind of mist system is being applied. Now, let us come to the sprinkler system in little more detail. As you understood, the sprinkler system can reach automatically to a point of fire before the fireman comes in. So, you see what are the components of a sprinkler. Maybe if you have got exposure to some commercial buildings, you can see that there is a sprinkler system on the overhead. They are usually on the ceiling levels, and there are at some distance you can see such kind of a thing which is hanging upside down. So, there is a deflector, and what happens, these deflectors are usually made of a very low melting point metal, and they have orifice which actually melts and allows water to rush out from that point and take action at the seat of at wherever the fire is, at the seat of fire, because it is immediately the closest one will get heated first. You see here it is written breaks at 155 degree centigrade or 69 degree centigrade, 155 degree Fahrenheit or 69 degree centigrade, and the control valves closes opening after the operation. So, what happens? These are placed in a network of pipe which allows water to flood or to sprinkle or deflect on top of a fire, which is the most common or the ordinary sprinkler system. Sometimes sprinkler system can be, you can see, upright pendant side wall, the mounting type. So, it can be sometimes on the side walls to check the fire from one face to other. Sometimes it is facing on the glass of a wall, glass within a wall, so that the glass does not melt because of the fire. So, it is kind of pushing the water or flooding the water on the wall, on the window only or the glass pane only. So, what are the components? It is again that system piping, water source, sprinkler, and that alarm which actually controls that valve. And that is that thermal linkage which I am talking of, which breaks and which allows the water to flow through the nozzle in different directions. So, these nozzle, from these nozzles the water jet flows and stops the fire. In our cases, mostly because it is in the ceiling, they are all pendant, that is hanging upside down. So, let us look into the calculations for a sprinkler design. So, what we need, if it is not a very hazardous building, should we put a lot of sprinklers? No. So, there are mandates which has been given or followed from the NFPA, which is National Fire Protection Association, and its standard, from its standard the points are taken. So, first is determine the occupancy hazard, then they determine the area and density. Say we have a room of 15 meters by 10 meters. So, we have to control we have to plan for the sprinkler system for that space. determine the total volume of water needed, because based on that the water pressure will be dependent. As I told, water pressure at every point has to be maintained. Determine the hose allowance. Now, these are all given in table depending on the pipe dimension, and we have to pick up the values to design our sprinkler spacing. Determine the total water demand to determine the total volume of water demand for the entire system. So, all these points are taken from the NFPA document. Now, you see here you have different kinds of hazards. As I told you, not for all hazards you have to put a sprinkler system of same spacing. So, light hazard, ordinary hazard group 1, group 2, extra hazard group 1, group 2 are the 5 categories what are categorized in the NFPA. Sprinkler at the point requires 7 psi of minimum pressure to operate, and also the water quality, as I have told you, they should not be affected microbiologically, because it should not be a static water, and that can lead to microbiological biological growths, and that can influence corrosion, because with running length the pressure also falls, and it can help in reducing the water pressure because of the along with the corrosion which always can happen within the pipelines, which are mostly cast iron pipes for water supply. Now, these are taken again the reference is given. So, these are the lists which have been mentioned in the NFPA document, which comes under light hazard, ordinary hazard, type 1, type 2 and the other hazards. So, you see here there is a graph which gives you on the x axis it is the density gallons per meter per square feet, and here there is an area of sprinkler operation in square feet. So, if you have given that an office space is 1500 feet square, here is this the red box. I am just showing you how to read the graph. This is 1500 feet square, and if it is an office space, if I would have gone into details of this chart, you would have seen that office space comes under ordinary hazard type 1. So, under ordinary type 1 and area 1500 square feet, we need density as in gallons per meter per square feet as 0.15. So, what you see, if you had to work out with millimeter per minute, you could have taken 6.1 millimeter per minute. We are working with foot scale. So, we are considering 0.15 gallons per minute per foot square. So, step 1 is the office space comes under ordinary group 1, area of sprinkler operation 1500. So, you multiply, you got the size. Density is 0.15 gallons per meters per feet square. So, what will be your water demand? 0.15 into 1500 gallons per meter, which is 225 gallons per meter. Now, what was our hazard type? It was ordinary hazard, and so what additional water or the hose stream allowance, that means the hose will contain some water or the pipe will contain some water. So, that standard water which will be required for ordinary hazard is 250 gallons per meter. So, 250 gallons per meter plus 225 gallons per meter gives you 475 gallons per meter, and the duration is for 60 to 90 minutes. So, because you have to charge the water for around 1 hour or 1.5 hours to control the fire. So, my water demand will be, this is per minute, and this when multiplied with my total duration of 60 minutes which is minimum and 90 minutes which is maximum will give me my total water requirement of so many gallons per meter. So, if I want to make a safe design or a better higher design, higher side design, we need so many gallons per meter, gallons of water. Now, if you need quick response sprinklers, if you need have a different kind of sealing. So, there are some guidelines for that which are included in this slide. I am not much elaborating on these. So, there are area adjustments. So, your 1500 square feet will be with having some additional, if it is having a sloping roof, because the arrangement has to be made, the water pressure will change, the height of the room you cannot exceed some 6.11 meters or 20 feet. So, if there are some adjustments are to be made. So, as a thumb rule, this is the way how, this is the chart which we follow for a standard space requirement, and the purpose of the room is important. So, what we have taken? We have taken from the standard this part, light hazard is there. So, if the room had a light hazard, my combined inside and outside hose gallons per meter, gallons per minute should be this 100. If it would have been an extra hazard building, it would have been considered as 500. Instead, in ours is ordinary hazard, we have considered 250 gallons for our case. Also, these slides are added, those who would like to take interest, you can even calculate the pressure loss. Because of running through the pipes, there is the Hazen-Williams formula, you can see here the pressure loss due to the running, because as I told you, you have to maintain a pressure. So, every time the total running length of the pipe also should be considered to design the sprinkler system. So, if it is a very large system, you also have to account for the pressure loss due to the running length because of the pipe characteristics which is given by this C, that is pipe roughness coefficient. Q is the flow and D is the internal diameter of the pipe. I am not elaborating much, but this Q is the amount of water flow and P is the pressure at the sprinkler point which you need as 7 psi if it is a foot pound system, and we have to calculate, the formula is given which is here, and this is the formula in liters per minute. So, that means, here it is the MKS system and this side it is the FPS system. So, the Hazen-Williams formula can give you the tool for working, is the tool for working the pressure loss. So, for a straight pipe, for a curved pipe, the calculations are shown, and these are the charts which gives you the pipe characteristic, the C factor, and we can actually utilize these data. These are standard data from tables, and we can use this. The equivalent schedule for different pipe dimensions are also given here, which you can refer. However, we move to the simpler part, which as architects we need to know, which is the sprinkler design or its layout. So, what you see here, a schematic has been given here. As you see, L is the distance between the pipes and S is the distance between the sprinklers. S gives sprinkler and distance between the pipe is given by L, and there are again standards given for normal or ordinary conditions, what should be the maximum L and what should be the maximum distance between the two sprinklers. So, L max is given, S max is given. So, if you have the L max and S max with you, you have to satisfy that your S value should be less than that or your L value should be less than that. So, you see here that is that pipe coming for the distribution system, and what is happening? It is branching out to different pipes. So, what is happening? At every point there is a pressure loss, and at each point you have to maintain a certain pressure, and remember the farthest point, that is this point, is the facing this point as well as this point will get the minimum pressure. So, we have to design for the, we have to have a design pressure OK for these points, and we have to plan for the distribution. So, what the manual gives? Manual gives you the L and the S, which with the dimension of this pipe, which will allow you to maintain at the end the maximum or the desired pressure. So, again you see there are lists for that, and if you see that is for the light hazard, then high pile storage which is coming under light hazard, next is ordinary hazard, next is high pile storage which is under hazard, and the extra hazard, they are all given, and for each of them these pipe dimensions or the distances are mentioned in foot and meter or foot square, their protection area in foot square and in meter square, or their maximum spacing in foot and in meter. So, in our case ours is an ordinary hazard, where you can see our area or protection area is given as 130 and maximum spacing is given as 15 foot. So, if you are given a space, office space, and the dimensions are given, each of the sprinkler which will have to cover 130, can at max cover 130 feet square and should be at a spacing of 15 feet. So, from this basic information we can always plan for the sprinkler system. Let us see for a small example where my office measures 150 feet cross 100 feet. You can see it here because things are, you can see here I am marking it with red. The office consists of various materials like carpet, wood, furniture, stockpiles etc. around, and is around 100 feet high. So, these are basically indicating that it is an ordinary hazard group 2 kind of building, which as I showed you in the previous slide, which has a protection area of 130 feet square and a maximum spacing of 15. So, those data are taken from here from the chart. So, because my length is 100 feet on one side, on other side 150 feet and my maximum distance is 15 feet. So, 100 feet divided by 15 or 7 feet rounding up will be my distance between the sprinklers, and width of the bay for each of them, if I consider 7 numbers. So, 100 divided by 7, the bay lengths will be 14.28, which is given, it can be maximum up to 15 feet, here it is there. So, we are less than 15 feet. So, what is happening? Area covered by one sprinkler is 130 maximum. So, divided by 14, if I consider my distance as 14 meters, 14 feet divided by 14 is 9.28 feet. So, what is happening that in step 5 we can see that what we are doing, we are offsetting my first pipe from the periphery of the wall with distance L by 2, That means, my pipe spacing will be L by 2 from the edge wall. On the other edge wall it will be again another L by 2, and my intermediate pipes lines will be at a distance L, which is equal to 14 feet, and this L by 2 is equal to 7 feet. So, if we see further, what will be my sprinkler spacing along that line or the length, there will be 150 divided by 9 sprinklers, that is almost equal to 17 sprinklers, and each of them will be serving my 126 square feet, which is less than 130 square feet, which is mandated. So, what will be again the location of the first sprinkler from the wall? It will be again S by 2. So, from the edge of the wall, if I go and show you here, so what is happening? This is the L by 2 distance, this is L distance. So, this is 7 feet and 14 feet 4 inches for the distribution, and here what we are finding, each of these 17 sprinklers are spaced at a distance of 8 feet 10 inches to round up. Now, how will this be fed with water? Will they be individually fed? There will be some cross which will be feeding all these pipes, and the pressure at the end point has to be maintained. It can be fed by a cross branch, and it can be done. It can be fed individually. It depends on how my overall planning of the water sprinkler system is done. It is shown for a single office space, which is 100 feet cross 150 feet. So, with this we come almost to the end of the presentation of the lecture, where we see the deflectors are also can be of different shapes, which I have already discussed: pendant type, upright, sidewall sprinkler. Thank you all.